guys can tell that I'm getting tired too. And you're getting tired. So let's do a spherical and cylindrical. I think you guys are getting more and more practice on those. And then on Wednesday, we do the little bit of a divergence and curl and stuff. It's just a little bit of memorization. What is important is I hear from the professors that teach courses that require 127, they want to make sure that you memorize divergence, curl, and gradient in this course and remember it then. Also, what they look like, that's another thing. You guys kind of know about the gradients in midterm 1. Now, for the final exam, we want you to know the other ones well. Okay, so here, find the volume of the solid bounded by z equal to 0, z equal to 4 minus y, and x squared plus y minus 1 to power 2 equal to 1. So what do you guys think? What should we do with this? Should we change the coordinates? Should we try to do, what should we do? I say, I don't see a lot of x squared plus y squared plus z squared, right? So my first instinct is to go with the cylindrical and see if it works. That's why we actually make you guys do them in both ways, to see that one is preferred to the other one. And that's the purpose that you do both of them. Now, I have x squared is plus y minus 1 to power 2 equal to 1. How do I do this? If I'm converting, and this is the shape, if I'm converting to cylindrical, z equal to 0 stays, right? And then z equal to y, 4 minus y becomes z equal to 4 minus r, what is y? R sine theta, right? And then what is going to happen to the last one? You will have x squared plus r squared cosine squared theta plus r sine theta minus 1 to power 2 equal to 1. Right? And I didn't, okay, that's okay. As so far, fine. So now, that one is nicely done. That's okay. And I can put the bound for z at the end, in the beginning, because z depends on both r and theta. That's fine. Let's see if we can simplify this one a little bit. So it's going to be r cosine squared theta plus r squared sine squared theta minus 2r sine theta plus 1 equal to 1. And that r squared sine squared is going to be r squared, these two, minus 2r sine theta equal to 0. 1 and 1 simplify. So what do I get is r equal to, and I can simplify, factor an r out, and I get r is equal to 2 sine theta. So that for r, and it seems like this is calling for basically, and this is calling for theta to be the most outer. Right? So I converted this boundary, that one stays the same. converted that boundary. It had both r and theta. I converted this boundary, and it ended up with r related to 2 sine theta. I guess it doesn't matter a whole lot whether or not theta is 1 before last or r is 1 before last. But it's already solved in terms of r, and I don't like arc sine as much as I like it this way. So now let's set it up. What you guys are not supposed to forget, again, z goes inside, then I'll put in r, and then I put in theta. What you guys are not supposed to forget? Jacobian. I hear Ali calls it Jack in the Box. And so it's R, and then, wait, it just says volume. So the integrand is 1, right? Z goes from 0 to that, 0 to 4 minus R sine theta. R goes from, see, R over here is 0, goes to this surface. If you look from above, R looks, if you look from above, R goes from 0 to these. Do you see that? That's the direction that R goes. And so R goes from 0 to 2 sine theta. And then theta goes from, so theta is also important. Where does theta goes to? Theta seems to be only in the, which quadrant? Theta is from negative x to, when x is positive all the way to x negative. So it goes from 0 to pi. So the shape is in the first octant and second octant. That goes with first quadrant and second quadrant. So that's why theta is going from 0 to pi. If you just look from above, theta goes from, is in the first and second quadrant. Because first and second octant, the xy part is sitting in the first and second quadrant.